start part C, role of data structures in algorithm. Yep. So this is a redo video, because the original video in class, later I found some big problem. The sound problem, most part of the video, the sound part is lost. Yeah. So I have to do a new one. All right. Yeah. So when I do a new one, I try to recover as close to our, class lecture as possible. Yeah. All right. Yeah. C.2, search unordered arrays. Yeah. So this is a simple question, but we can learn a lot of things from our second computing problem. Problem number 2, search unordered array. First, let me give you the problem description. Given an unordered array, and we use notation capital A, array with indices from 0 through n-1. And there are n elements. So here, the number of elements, we need to do the data processing. So here we call the data size. Here is n. Yeah. So here, the first time I use this data size concept. Yeah. Later, I will spend some time to explain meaning of the data size. Yeah. All right. And a search key k. Yeah. The known values. Our goal, we need to find an index I such that k equals a of I. Yeah. So it's a simple computing problem. Yeah. So this problem belongs to type, search type. Yeah. So for this class, we will learn 3 basic problem types. The first one is this search type. Right? The second one, sort type. The third one, selection type. So these 3 basic problem types in our algorithm class. All right. The data structure used here, simple array. All right. The reference, I give you section 2.1. Yeah. Starting from this point, later on, we will follow the natural order of our textbook. So we usually do not jump here and there, following the natural order. Yeah. So in the part B, we select materials from section 6.5, because we want to do a project as early as possible. Yeah. Some interesting project. Yeah. So I select that topic. All right. So let's look at the role of the data structures. Why the data structures are important in algorithm design. Yeah. Remember, in our previous, we did one example before, so that is the chessboard question. Yeah. In that example, I pointed out one thing. We need to do one special step when we do problem solving. So that is organizing the data. So here we will get that point again. Yeah. So the data structure, the reason we need to choose appropriate data structure in our problem solving, through data structures, we can make our data well organized. Here you can see we address that important objective. Make our data well organized. Yeah. If the data is not organized well, so distributed in some random way, then it's not easy to find the data you want. If you organize your data in some, special way with good structure, with good property, then it will be much easier to find the data you need. Yeah. So, all right. Find the required data faster. Then your overall performance will be improved. Yeah. Yeah. So that's the basic idea. Yeah. All right. So here, because this is the video, I redo the lecture in class. Some students asked questions. So here I try to, repeat those questions. Yeah. So one student asked questions because for an array, all the data items are arranged by their locations. Yeah. So the locations in the main memory. Yeah. So that means you can access all those elements through array indexes. Yeah. So that student felt that the data is organized. Yeah. So here, if the data is organized or not, because we need to ask the question, how strong is the data organized, right? Yeah. So there is a difference in the, how good you organize the data, right? Yeah. How strong? Yeah. So that question. Yeah. All right, so here at this level, so data is organized by its locations. Okay, yeah, so this is one way to organize the data. But this kind of organization, so it's weak. Yeah. It's pretty weak. Yeah. Why we feel it's weak? Because if you want to find an item in the array, you need to make a lot of effort. You need to search the whole array to find it. You need to make a lot of effort. It's, it is not fast. Okay? It is the search. Not fast. Okay? Yeah. It's pretty weak. Yeah. Another situation, we want to make data organization much stronger, right? Much stronger. Yeah. So here I give you, strong way to organize data. Order the data. Order the data. Yeah. Here it's an unordered array. Yeah. So that's a big difference. If the data is ordered, then we can find a required data much faster. Yeah. Here for an ordered array, we can apply binary search, right? We know the binary search is much faster than the search we are going to apply here. Here we call the linear search or sequential search. Yeah. Much faster. Yeah. So then we can treat ordered data. That's a strong organization, right? Yeah. Stronger. We organize our data in a stronger way. Yeah. Here unordered data, so we treat, so although you can treat, you organize your data in certain way, but it's a weak way, very weak way. Okay, yeah. So look at that difference, that big difference. Okay, yeah. Another important point I want to point it out is, yeah, so because here I talk about the binary search. Yeah. Everyone knows the binary search, right? Yeah. So you can do the binary search right now. Yeah. But the binary search topic, that's in our module 4 topic. Yeah. Because in order to do the binary search, we need to apply divide and conquer approach. So that is our module 4 topic. Divide and conquer, that topic. Okay? Yeah. So we will learn this topic in module 4. Yeah. 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 So then, another important thing you need to pay attention here is, so in the real world situation, you need to be very careful when you determine if you want to apply sequential search and binary search. You need to look at your data. Is it unordered array or ordered array? Yeah. So many people, when they apply binary search, so they don't look at what kind of data they have. Yeah. They just apply it. Yeah. So that's quite common. So many people apply the binary search on unordered data. So the result, you can imagine, it's ridiculous. Okay? Yeah. Make sure before you apply the binary search, you need to check if the data is ordered. So that is very important. Yeah. All right, so let's continue. Yeah. So here. Yeah. Yeah. So when we do analysis, here I want to introduce a concept called the basic operations. Yeah. Basic operation. Yeah. Because when we solve a problem, usually we need to use many different operations. Yeah. So for example, in our first problem number 1, evaluate polynomial. So we need to use addition, okay, multiplication, right? Okay, yeah. Other than that, you may need to use other operations, right? Yeah. For example, assignments, and so on. Okay, yeah. Comparison, yeah. So here, this one, comparison, another commonly used operations. Okay, yeah, yeah, yeah. So for all those operations, we want to use this concept, basic operation, to represent one particular operation that contributes the most in the response time. Yeah. Okay? Contributes the most in the response time. Okay? That's the basic operation. Yeah. All right. So for example, for our problem 1, multiplication contributes the most in the response time. So we treat it as the basic operation. Okay? Yeah. All right. Yeah. So here in this question, when we need to search elements in an unordered array, so we treat comparison. That is the basic operation. Yeah. Other than comparison, we need to use assignment, right? Yeah. You need to use many assignments. Yeah. But if you compare comparison and assignment, you can see, yeah, we will use comparison operation much more than assignment operation. Yeah. All right. Then let me go through the basic procedure. Yeah. All right. Compare K and A of I first. Yeah. The current element. This A of I, we treat it as a current element. Yeah. But we need to start from the very beginning, the first element. So the initial value I equals 0. Yeah. And then when we do comparison, we consider two cases. The first case, K equals A of I, and the second case, not equal. Here you can see the greater than, less than, those two cases, we combine it as one unequal case. One unequal case. Because we don't care K greater than A of I or K less than A of I. It's not important. So we don't need that information. Okay? So we want to make it as simple as possible. So here we use the unequal sign. After that, if it's the equal case, then the function returns the I index value and it terminates after that. Okay? Yeah. The second case, unequal, then you need to do next iteration. Okay? So you increment index I by 1 to get a new element, then do another round comparison and check those two cases. Yeah. So we keep doing things like that. Eventually we have to stop. Okay? So at some point at the end, because after you compare K with the last element, yeah, where I equals n minus 1, the last element, yeah, if you cannot find a match, okay, match K equals A of I, then it fails. The element search process fails. In that situation, your function returns the -1 value. Yeah. Because this value, people can quickly see it's not a valid index, not a valid index. So then it must have some different meaning. The meaning is no match. You cannot find any element that matches the given key. So it's the no match case. Then the function terminates. Yeah. So that's the whole process of this algorithm. Okay. Yeah. All right. So that's pretty easy, pretty straightforward. Okay. So then later we will do a lot of discussion based on this process. Yeah. All right. Yeah. So this algorithm, we call it either sequential search or linear search. Okay. Yeah. All right. Next. Yeah. Now we need to do analysis, right? Yeah. So do the counting. Yeah. So we need to do the counting here. Yeah. What do we count here? We need to count the number of comparisons. How many comparisons we need to find a key, find an element that matches the given key, or no match. Okay, there is no match case. Yeah. Okay, so here I list all the possible cases here. Okay, yeah. So the first one, the key matches the first element, second element, and so on. Okay? Yeah. After the last match case, and there is no match case. Okay? Yeah. So we need to cover all the possible cases, yeah, in our discussion. Yeah. Then The second row, we count the number of operations. Here, number of comparisons. Now, if k equals the first element, a of 0, then 1 comparison. If k equals the second element, 2 comparisons, and so on. Okay? The last element, k equals the last element, n comparisons. Okay? Yeah. No match case, you need to do n comparisons. Yeah. Here, you can see. Yeah. Yeah. So you get the number of comparisons for all the cases. Okay? Yeah. So among these cases, so we can say the best case is 1 comparison. That's the minimum number of comparisons we need for a very special input. So when your input is very special, you can get this best case. Yeah. The other side, the worst case. Yeah. So we have 2 worst cases with n comparisons. Yeah. Yeah. Worst, okay? The maximum number of comparisons you need, n comparisons. All right. Then, now I want to ask you one important question. How to measure the overall efficiency? Overall efficiency. Okay? Now, because when we talk about an algorithm, we want to explain our algorithm to other people. Yeah. Most of the time, we want to tell them what is the overall efficiency, right? Yeah. So that's important. Yeah. Can you use the best case efficiency? No, because you are too optimistic, right? Because most of the time you cannot use 1 comparison to find a solution. No, usually much worse than that. Okay? Yeah. Can you use the worst case efficiency to describe the overall efficiency? The answer is still no, because you are too pessimistic, right? Most of the time you do better than the worst case, right? Yeah. So you can guess the appropriate way for the overall efficiency. It should be some number between the best case and the worst case. But what number is the best one to describe the overall efficiency? Yeah. That's an important question we want to study in this section. Okay? Yeah. The overall efficiency. Yeah. All right. Here you can see here we want to find a fair way to describe the average case efficiency. Yeah. And the measure should include all the cases. You cannot miss any case, right? Yeah. So the overall one must cover all the possible cases. Then you can say overall, right? Yeah. You cannot miss even one of the cases. Yeah. So that won't be complete. Okay? Complete way. Yeah. How to know all the cases? Here we know. Here we list all the possible cases. Yeah. Later in other questions, yeah, you need to answer this question. You need to list all the possible cases. Later, future, other, questions. Yeah. How to combine all the cases? The next one. Now we are at a point. We need to combine all the cases in a fair way, right? Yeah. So what's the fair way? Here. No. Do you want to? Yeah. So here, one possible way that many people may want to try That's the average of all these numbers. Think about the average. Yeah, so here, so one way that most people average of all the numbers. Okay, yeah. Average of all the numbers. Yeah. It looks very reasonable, right? But here the question is, what's the meaning of average? Is there a clear meaning of average? When people talk about average, is there a clear meaning of average? Sometimes it's pretty vague, although we know, yeah, most people has a specific meaning. Yeah. But you need to be very clear about the meaning of the average. Yeah. It could be different. Why? Yeah, because there is another name for the average. It's called a mean. Okay? Yeah. So some students know the mean also means the average. Okay, mean. Yeah. In math, there is a concept called a mean. Okay? Yeah, average. Not a median. Okay? Not a median. Later we will talk about median. Okay? Yeah, not a median here. But regarding the mean, there are several different means. Yeah, the definition, the mean, different. The first one is arithmetic mean. Arithmetic mean. Okay? This is our usual average. Our usual average, we mean the arithmetic mean. Okay? Usual average. But there are other means. Okay? Geometric mean. Geometric mean. Okay? And another one rarely used, harmonic mean. And so on. Okay? Yeah. We can even have more other means. Yeah. Rarely used, but people can define different means. Yeah. All right. And here, our average, we should have some specific mean here. Okay? Yeah. All right. So in order to describe the average, what kind of mean we want to use? Yeah. So we need to make some assumptions, make appropriate assumptions. Yeah. Yeah. And assumption should be fair. Okay? Yeah. Should be reasonable, reflecting the real world situations. Okay? Yeah. Yeah. And how to do the right way average, calculating appropriate average to provide the overall efficiency. Yeah. So that's our next topic, C.2, next topic.